Greetings, friends of the universe. Greetings, friends of the universe. Today we are going to talk about the reptilian extraterrestrial race. What is their history? What is their impact on our galaxy? And what are they doing on our planet?
Hello, everyone. First, I wanted to thank you for being all there at droidCon Berlin. We had so many great quality talks so far. It's not over yet, so if, like me, you think that Android is awesome and reptilians suck, then you're at the right place. Oh, and before we start, pardon my French, I mean accent. My English is still experimental, it's like in developer preview. Sorry about that. So Android is awesome, and especially as a developer, because, I mean, look at our IDE support, our language, our build system, our libraries. It's a real pleasure to have that level of quality tools to help us developing applications in our daily lives. And another cool thing with Android is that the code rewrite can run on so many different hardwares. Android is like everywhere. The Android apps rewrite can run on phones and tablets, watches, TVs, cars. And now with Android things, we can target a new category of devices, our own homemade devices. And that's huge, because now in 2017, if you can build an app, you can build a device. You can make crazy devices, such as your own 8-bit distributed piano to play Sia's Titanium song or whatever you like. If you prefer to play music like a scientist, buy yourself some beer cans, a capacitive touch sensor, and write an Android app to detect touch events so you can start playing electronic music. If you're into cute stuff, you can build a lucky cat that moves its paw every time you receive a notification on your phone. Here, I'm using Bluetooth low energy, but you can really use whatever you like. And last example, if you like chocolate, you can create a robot powered by the Google Assistant that tells you some jokes and gives you some sweets. Give me a chocolate bar.
Here you are.
What's interesting here is that you don't need to own a 3D printer to get started. You can just use cardboard. Cardboard is great for prototyping, you know. And here, I just created a robot made of a shoebox. I had some shoebox. I can just use cardboard for that, and it's great. So I have a Google Assistant robot now, and if you're not familiar with the Google Assistant, it's an intelligence technology inside the Google Home device. It's the same technology. And this technology provides a conversational interface to Google, and you can embed that exact same technology in any of your Android or Android Things project. Not only that, but you can also extend it to your custom needs. In that case, understanding that I want some chocolate bar and give me some. So I just extend the Google Assistant. You can do that in any Android Things project. All those projects you saw were made with Android Things in less than a day each. It's very important to know that. So you can really create fun stuff like really, really quickly. Oh, and you may wonder now something like, OK, but why using Android Things? Because to be honest, if we exclude the Google Assistant robot, all the other samples could be done just using an Arduino. And that's fine with that. And also remember that if you need to build a very simple, limited device, Android Things is like overkill. Just use an Arduino if you can. You know, Yagni, KISS, those principles. You can use Android Things if you want to try it. Of course, that's a good reason. But if you want to create a very simple, stupid device, just use an Arduino if you can. Android Things is not targeted for those kind of devices. Instead, it's a very good platform for devices that requires a large amount of computation power, such as security cameras or smart doorbells, for instance. If you want to embed some artificial intelligence or do some local image processing without having to consistently ask some network services to process images and then return results, then Android Things can be good for those use cases. Don't forget, Android Things is Android. And I may repeat that a lot. Android Things is Android, don't forget that. You can, if you want, create an IoT device using Java, Kotlin, retrofit the architecture components. You can test your IoT project with JUnit and Mockito. You can, of course, use all Google services too. So let's say that you need pushes. Just integrate Firebase Cloud Messaging as you would normally do in any mobile project, and like 5 minutes later, your IoT device will be able to receive pushes. So you have a really great interaction with Google services, and that's awesome. If you need a secure platform, Android Things is a good choice. It's secure and up-to-date. You only focus on writing the application part. You write your app, and Google is in charge of embedding your app inside an Android operating system and delivering firmware security updates to your customers. So let's say that even you bought an Android Things device that isn't maintained anymore by the manufacturer, Google will still publish security updates. Even if the manufacturer does not publish any more updates, Google is responsible of updating the operating system. So you will always receive security updates. And that's great because security is one of the biggest issues with IoT devices. And it's not really one with Android Things. Finally, not only Android Things is great for prototyping stuff quickly, but also it's designed for building professional mass market products. Here's a list of compatible boards so far. If you're a maker, you want to prototype or build some stuff for fun, I suggest you to go with a Raspberry Pi. It has a huge community behind it. It's great. If your goal is to build for mass market, then you may want to start with the NXP board, because those kinds of boards have something really cool called the system on module. And on the left, you can see a Raspberry Pi. And on the right, you can see an NXP board. As you can see, they look really, really similar. But if you look closely, you'll find out that in the NXP board is actually composed of two boards stacked on top of each other. The top smaller board is a core compute module we refer to as a SOM, or system on module. And that small chip on the top has all the core elements required to run the Android Things operating system. So your app will be there, Android system will be there. This little board has storage, Wi-Fi, everything to run an operating system. And the base board that is underneath is just an extension to that small system on module, just to give you access to a lot of different components if you need. Well, it's cool because if you are planning to build for a lot of, like for mass market, you are planning to build a lot of devices, just buy a very small chip, a system on module, and create your own custom board underneath that only includes the components you need. This is an example of what you can do. Google engineers wanted to create a smart candle, you can see on the right, that only adds 2 LEDs and USB for power. So instead of using that large baseboard you can see on the left, they just decided to create their own custom baseboard. And it's actually something really easy to create because all the complicated hardware and software stuff is inside the system on module. And you will not have to touch with that. So you can really create your own custom board if you need. If you don't need, if you want to prototype, you don't need that. You can still stay with the one on the left. But if you want to build something smaller and cheaper, it's great. And another advantage of some system on modules is that they are already certified for regulator approvals. You know, when you want to ship a product, you need to pass some certifications before it enters the market, like certification for Bluetooth, Wi-Fi, that stuff. And those take time and are expensive. With Android Things pre-compatible system on modules, they are already pre-certified, which means that it will save you a lot of time and money because you won't have to go through certification process again. So now you understand why Android Things is a perfect platform for prototyping, but also for production. Android Things is great. Yeah, I think we all agree on that. But you know, there is another reason why I'm here today. It's actually to tell you about our world as human beings, and especially about what's wrong in our society. As you know, humans don't use their brain to its full capacity. We are always distracted by media, entertainment, and politics. Also, borders, country lines lead to endless wars and conflicts. The reason for that? Reptilians, of course. If you have never heard of them, reptilians are aliens who are living in our planet and controlling us since like thousands of years. And those lizard people are still among us. And it's crazy because reptilians have altered our DNA. So we can't use our brain to its full capacity, making us easier to control. They control us by distracting us with media, entertainment, and even politics. They created the laws to restrict us, and they have, through the generations, ruled the world. And you can't tell it because they are shape-shifting. They take the appearance of humans like us. And until now, we could not do anything against them. We were harmless, and they were laughing at us. But now that Android Things is released, it's a different story. Here's how you can build a machine that detects and exterminates those lizard people. As you may know, humans are unable to detect reptilians, but of course artificial intelligence can, so we're just going to use TensorFlow, which is an open source library for machine learning developed by Google and currently used in many of their products like Search, Gmail, Maps, YouTube, and many more, photos too. If you haven't tried it yet, I suggest you to follow those 3 code labs, especially the TensorFlow for Boyd Code Lab. I will share a link to the slide at the end of the talk so you can later take the footnotes and see those code labs. They give you a really great introduction of what TensorFlow is and what it can do. Today we will use an existing neural network model named Inception 3. This model was trained for a really long time to recognize objects, fruits, or animals inside pictures. So Google trained this model with millions of images for a really long time. But you know, it's kind of useless to recognize fruits inside a picture. I mean, who cares? What we need to do is to recognize reptilians. So we will keep this model knowledge, but just retrain it a little. So instead of recognizing fruits or objects, it will recognize what's important for us, which are humans, reptiles, and reptilians. So first, for that, you need to gather a lot of images. So I downloaded many pictures of humans, reptiles, reptilians, and placed each of those into separate directories. 3 different directories, 1 for each category. Then we launch a script from the TensorFlow Git repository. This script actually downloads the Inception model and keeps all the knowledge, but just retrain it a little with the provided image. So once completed, it generates 2 files, a protobuf graph, which is a neural network model. It's a large file, and a labels text file that only maps results to human readable names, because TensorFlow will give us something strange. And thanks to this file, it will map to human, reptile, reptilian. Those are actually the names of folders. We also need to optimize our graph so it can work on Android, because you know, really quickly, retraining a model takes a lot of time. Like, you usually retrain a model, a neural network model, on a desktop or a clone machine, but you will not retrain a neural network model on Android. That's not really made for that. What we want to do on Android is do something called inference. That's why we will start a script named Optimize for Inference. Inference is like providing a model to TensorFlow, and TensorFlow will browse all the model to infer, to determine what's on the image. So we need to optimize the model for inference, which means that we will remove all training-specific operations, and we will only keep inference-specific operations just to keep those models smaller so it can work on mobile, like on Android or Android things. OK, now our model is retrained, and we want to test it to know if it can really distinguish humans or reptilians. And lucky for us, we have an official TensorFlow sample on GitHub made by Google. So you just clone this project, you insert your own neural network model inside, and you can run the Android application. If you're curious to know how it works, actually it first creates a TensorFlow inference interface using our neural network model and the labels text file. For each picture that comes from the camera, the doRecognize method is called. The application first converts the bitmap into an array of pixels, simply because the neural network model was trained with that data format. And then we feed TensorFlow with those pixels data. We run the inference layer up to from the input node to the output node. And finally, TensorFlow fills an outputs array to give us like some statistics. For example, if we give this image, this picture of a normal man, TensorFlow will fill the outputs array, so you can see this man is like 1% reptilian, 0% reptile, I mean, of course, and 99% human. So this person is harmless, we're confident it's a real human. And now we will test our own neural network model we retrained with a bunch of random pictures that I found on the internet. A random guy, a random lizard, a reptilian, another random guy, and Obama photoshopped as a reptilian. Don't ask me why, I just found that on the internet. So we're just going to launch the official sample with our own custom model. With the picture of the random man, you can see on the top written that TensorFlow infers, tells us that this person is like 99% of chances it's a human, no problem. This is, of course, a reptile. TensorFlow tells us 95% of chances it's a reptile. This is obviously a reptilian, 96% of chances this is a reptilian. This is very interesting, but I didn't know this man, but TensorFlow tells me there are 99% of chances it's a reptilian. If you see this man, run away, really, really. So Obama photoshopped as a reptilian is obviously a reptilian. I mean, it's Photoshop. I mean, why? Oh, I also tried with this man, and TensorFlow can tell us it's Equaton. Of course, TensorFlow can recognize. And big problem here, TensorFlow tells us 50% reptilian, 50% Equaton. It's huge. You understand what it means? We didn't want to face that truth, but it turns out Jack Wharton is a crossbreed reptilian, according to TensorFlow, not according to me, of course. And that could explain a lot of things, like why he's so much smarter than us. Because he actually can use his brain to its full capacity. I mean, that's so obvious, the truth was right in front of us all along. That's crazy, but let's forget Jack Wharton for a while. We have tested our model, and it works like really, really well. Like, it tells them some truths we didn't want to hear. Oh, and if you wonder how TensorFlow could actually recognize Jack Wharton, it's because I had something to you. I didn't create initially 3 different folders, but 4 different folders. One with pictures of human, reptiles, reptilians, and another one with pictures of Jack Wharton. So you can really see how well TensorFlow can recognize faces and people when you provide like a bunch of pictures. Okay, our neural network model is like really okay, and now we can create an 100 things project to integrate that. And to create an 100 things project, it's easy. You just start Eclipse, click on new file, new Java project. No. I'm joking. Don't exit the room. We have no chance against reptilians if we use Eclipse. No. Let's start Android Studio 3, of course. We create a new project with Android Studio 3. You can tick the Android things project, so you can create a project directly with Android Things. Android Things already runs on Oreo, because remember, Android Things is always up to date. And let's take a look at the generated files. First, it creates an Android manifest file, as you already are familiar with. Just some slight difference, like a use library tag and an IoT launcher intent filter. Why? Because the Android Things operating system needs to know which activity it should start. Remember, Android Things is Android. It should know which activity to start, and the IoT launcher intent filter just tells the Android boot software to start our main activity. Just something very similar. Just some slight difference, but you don't really need to care because you know when you create a project with Android Studio, it already generated the boilerplate for you, so you don't need to actually care. But it's always interesting to know how it works under the hood. Okay, it also creates Android Studio also generated a main activity file, and notice here the set content view call. So you are already familiar with that kind of thing. It's really, really similar to what you're already used to. But here it's very interesting because there is a set content view call, and you know you can manipulate layouts with Android things, but you can also not do. It's up to you whether your device has a string or not. If you're building a paper-like robot, you will need a screen, and you can just use a find view by IDs, XMLs, stuff like that, relative layout, that's so cool. And just so you can know, here's an example. I created a simple frame layout with 2 images, one for a background and one for a picture of reptilian. And if you connect your screen to your Android Things board directly, it will work out of the box. You have nothing to do. I also applied here a rotate animation the same way you would do on any mobile application, just to tell you that it works like out of the box. You can just find view by IDs, get reference to your views, just animate your views exactly the same way you would do on any Android mobile device. So nothing difficult here. You can use XML layouts if you want, but you can also not do. I mean, if you're building a Roomba-like robot, you won't need a screen because it's kind of useless for over. But you may want another kind of user interface. You don't need a visual user interface, but you may want a vocal user interface. And for that, just integrate text-to-speech. It's the same API, so if you want to integrate text-to-speech or any other thing, you can. And of course, Android Studio generated a last file, the build.gradle file. You are familiar with that. But there is a new dependency called the Android Things, I would say, support library. It's a library specific to Android Things that lets you communicate with external peripherals, like all those different stuff. And if you're new to electronics, which is my case, you don't need to have an electronic background to get started with Android Things. You can just learn on the internet. You will find everything you need. What I suggest you, if you can, is to buy an Arduino starter kit, because those kits usually come with a lot of different sensors, actuators, a documentation, and code samples. So it's very, very good to get started with electronics, because you will have everything you want, and then you can just reuse all those components in your Android Things project directly. So how can we communicate with those peripherals? The Android Things library uses industry standard protocol interfaces such as GPIO, PWM, S2C, and others. The first time I saw that, I was like, come on, it looks so complicated. Actually, it's just some naming. It's really simple. Those are just ways to communicate with peripherals. And when you buy a peripheral, it's usually specified which interface it uses. For instance, if you want to use this LCD screen, it's written that it uses the I2C API. So you will connect it to your I2C pins of your board and use the I2C API from the support library. Here we want to blink an LED, that's always the first step. So we first connect the LED to our board. An LED is a GPIO device, so we can connect it to a GPIO pin of our board. Well, the one we want, for example, I chose BCM4. You have a lot of articles on the internet telling you how to plug components if you don't know how to. And that's simple. It's like Lego once you're a little familiar with that. And then we use the peripheral manager service from this Android Things library. This class gives us reference to peripherals for a given name. For instance, here I want my LED. So my LED, to get a reference to my LED, I call the peripheral manager service and the open GPIO method to open the GPIO at BCM4, which is where we connected our LED. And to turn it on, we simply set the LED value to true. And now the LED will be always on. To turn it off, you set the value to false. You know, that's easy. And it's not even 5 lines of code to blink an LED. And if you know what a Boolean is, and I think you should, then you know how to turn on LEDs. That's the same stuff. Of course, you can use prettier LEDs if you want to, because those were pretty ugly. Back to our LCD screen. Instead of opening a GPIO device, our LCD screen was an I2C device, so we will use the open I2C device. And similarly with a name. And to display some text onto this screen, we will use the write method from the I2C device and just pass a byte array, a buffer. So that's how you communicate with peripherals, with external peripherals. It's all about reading or writing data. That's so simple. And as you can see here, all the code is written in Java or Kotlin, which means that if you want to create a driver to simplify using a component, for example, if you want text to scroll on an LCD screen, you can just write a standard Android library, and it will work, and that's cool. It's not a specific Android Things library. A standard Android library is OK. Drivers are already available for all those components you see here and many more. If there are no drivers for a given component, what I suggest you is to find the driver on Arduino and just port the C Arduino code to Java. It's like really simple. It may take time, but it's simple and it's really usually easy. For instance, if you want to use this I2C screen for your IoT project, just connect it to the I2C pins of your board, and once again, the internet can tell you how to. Import the existing driver made by Google or the community. Hopefully, we have one for that. And you can start using it and turn on pixels manually. Like you set the pixel X, Y to on or off. And this driver also has a nice method. So you can directly use the Android bitmap API to directly send a bitmap to your device. Very, very simple. You see 1, 2, 3, 4 lines of code to send a picture into a custom peripherals thanks to a driver made by the community. Now back to our generated Android Things application. So we have created a project with Android Studio. And how to add TensorFlow inside? Well, that's simple. Android Things is Android. Everything you used to do on Android, which is we used to have an Android application testing TensorFlow, we can just take the code, put it on the Android project, Android Things project, and it will work. We can also use the official Android Things TensorFlow sample, which is actually doing the same. To take picture for our project to detect reptilians, you can buy a camera. Once you plug an official camera to your Android Things board, it will work out of the box. You can just use your camera API. Oh, and if you're not into detecting lizard people, that's fine. I'm not judging you. Here's another example of why it's interesting to use TensorFlow on an IoT project. This farmer in a farm created a TensorFlow project that can sort cucumbers by size, shape, colors, and everything. So you can really have a lot of use cases with TensorFlow or embedding artificial intelligence inside an Android Things device. But you can also, for example, create a machine that takes pictures of PCs in the production line. And every time TensorFlow tells us that this PC seems to be broken, like 60% of chances it's broken, your Android Things project can directly stop the production line as fast as possible to detect error faster, fail fast. So, but we don't want to take pictures continuously. What we want to do is actually we want to have a machine that takes a picture when somebody is approaching our device. For that, we use a ultrasonic sensor This sensor uses a sonar to determine distance to an object like bats or dolphins do. If you're interested to know how it works, it actually use two GPIOs. When you set the trigger GPIO, so the trigger boolean to true, it will start emitting a sound wave. And the reflected wave comes back. The other boolean, named echo, will be set to true. So depending on how long it took to send the sound wave and get the echo to true, you can determine the distance to an object with a very simple formula. So what we're going to do is we will import the official driver to use that. Oh, I forgot there are no drivers for that component. So what we can do, I mean, right now we have no time to create a driver for 100 things, even if it's easy to do for that kind of driver. So we will we will use an Arduino directly. So if you don't have time to create a driver, just plug your component to an Arduino, connect it to an Arduino, write an Arduino sketch that forwards the distance, in this case, to the serial port, connect the Arduino to Android things, to the USB port, and just read data from the serial directly inside your Android things project. Here you notice that I created a simple, very simple live data wrapper, and it's another use case of where you can see it's really Android APIs. So I observe from the serial port, and sometimes I have some distance, and every time it emits a distance, I just log so far. So you can see when I'm approaching my phone, you can see the distance is like 23, 15 centimeters, 10 centimeters. OK, so it works. What we did is we just used an Arduino as a proxy, because we didn't want to spend some time to create a driver, so you just use an Arduino as a proxy, it will work. So what to do now? When somebody is 25 centimeters from a machine, we will take a picture. And of course, if he's a reptilian, we should obviously exterminate him. Oh, wait, I forgot. We do not want to kill Jack Wharton, because I mean, he helped us so much. We just can't do that. That would be we would be really bad people. OK, our device cannot detect reptilian, but now it needs to exterminate them. And for that, I found 3 possible ways. So option 1, using a gun. First, to use a gun, you need a servo motor. This is a very simple component. A servo motor is a PWM device that moves its needle to the angle you want, from 0 to 180 degrees. So you connect this to your board, to the PWM pins of your board. You will see it's really like Lego. You just connect, that works. You import the official driver from the community. You initialize it. That's just some boilerplate code. Wow, this servo can move from 0 to 180 degrees. And you move the servo motor. To move it, it's just one line of code. You set the servo motor angle to the angle you want, here to 42 degrees and then to 0 degrees. So one line of code to move a servo motor. But it's a servo motor, that's cool, but oh, it can kill people. You buy a gun, you buy a rope, a servo motor, you attach everything together. When a reptilian is detected, you move the servo motor to a specific angle, so it will move the rope, so it will trigger, it will pull the trigger. So now let's arm the gun and try again. Replay. Yeah, that should work. One line of code to kill people. Oh, and of course, you hide the gun behind the fake wall, otherwise people will notice there is a gun and they will not approach the machine. That's normal. And you will also have trouble. Option 2, because you know, finding a gun is kind of difficult in some countries, especially in France, and if I had one, I would not be here today. So I decided to use option number 2, which is more safe, just using a flamethrower. Oh, I won't do any live demo here, because you know, live demo always fail eventually, and I don't think you will like me a lot if my demo fails and you are on fire. So no live demo today. Again, we will need our best friend, a servo motor. You remember to set the angle, you just one line of code, servo.angle, blah, blah. But we need a stronger servo motor because that one was too cheap, like made of plastic. It's just the same thing. It's another servo motor. It's just more expensive, stronger, but it's exactly the same thing. You use it with one line of code. You also need some rubber bands, a candle, and a flammable spray. Attach everything together and try moving the servo motor. OK, it works. Now you add a candle. And when a reptilian is detected, you change the angle programmatically, so it will throw inflammable liquid onto the candle. Well, I tried, but my flamethrower was not that impressive, so instead you can look at other people who made a better project than me. It looks really crazy. You can do that with Android things in like 2 or 3 days. I'm really serious. Oh, and don't do that at all, kids. Don't do that at home. I mean, my flamethrower was not impressive also because I didn't want to die stupidly. So as you can see, this machine is controlled remotely. If you want to add remote control to an Android Things project, you use the same API as you use on Android. So you use nearby connection API if you want Bluetooth Ali. You can embed an HTTP server, use whatever you want. Well, the flamethrower was not violent enough. So let's exterminate reptilians with option 3, which is using a chainsaw, because you can. So first you need a relay module. To understand what a module is, a module, you have to think like it's like a Java library, like retrofit or Java. You know, a library is something very complex under the hood, but accessible via a very simple contract. And a module is like something similar. It's a lot of complicated components, but accessible via a simple contract, a simple interface. And for instance, once you connect this, you can just use the same GPIO APIs you use with LEDs. Remember, booleans, true or false. So to turn on a high voltage device, you simply set the value to true or false. It's perfect for home automation, coupled with the Google Assistant to turn on or off a fan, a heater in one line of code, value equals true or false. But we're not here for home automation. I mean, we have other important things to do. So let's use the relay module with a chainsaw. Here's the plan so you can appreciate my game skills. When a reptilian is detected, a relay module will start the chainsaw, set value to true. The chainsaw will fall down from a fake roof to our target. We also need another component, which is an LED strip. Why do we need an LED strip? Simply because it's pretty. And it will add some colors in our life and over reptilian's blood. It will look really great. So here is what it looks like. You can see the colors are changing. Red, green, blue, purple, red, purple. How do you do that? I actually use an LED strip here to show you that you can use the same components from the Android SDK into your Android Things project. To animate the LED strip and to change the colors, I simply used a value animator that loops through the color spectrums for 8 seconds with an update listener to write the new animated color to our device. So you don't have to understand everything here, but just the most important idea is that it's a value animator, something from the Android SDK to animate stuff, and I actually used it to animate my chainsaw. And to animate it at a given speed, I simply used a value animator with a custom path interpolator with a predefined speed, because you know you can do that with Android animation, so why can't you do that in Android Things? You can, of course. And that's fun because, you know, Android Things really use Android SDK components. And when value animators were created, like nobody would have guessed one day somebody would use it to turn on a chainsaw. I mean, that's completely insane. Value animators can kill people, and that's so cool, actually. And I think we are done. Reptilians are like completely afraid now, machine learning, Android Things, a lot of different stuff. To conclude, Android Things is fun. First thing you need to know, Android Things is fun. If you already know Android, it's so easy to get started with Android Things, so I strongly encourage you to give it a try. In only a few days, you can start creating nice projects, even with no electronics background. Android Things really accelerate and simplify the development of secured IoT devices, because it's an always secured platform. Reptilians suck, obviously, and just try Android Things. Really, you will learn new stuff, you will make fun of useful stuff. You already know how to create apps. Now you can make devices. That's huge. If you want to try Android Things, there is a workshop today at 2 p.m. hosted by Roma. Very limited places, so come early if you really want to attend this workshop. We will provide you some boards, and you can just try Android Things. And that's all for me. Feel free to follow me on Twitter for fun stuff. Slides are available online already, so you can just take a picture, check the footnotes later if you're curious. We may have time for questions. Otherwise, just feel free to ping me on Twitter if you want to, or yeah, I will be around today. So if you want to discuss IoT, Android Things, reptilians, whatever you like, I will be there or on Twitter. And many thanks for your attention.
Yes, we do have time for questions, but first, thank you for the talk and for saving the world and for giving me an idea what I can really do with my chainsaw, which I have back home in my shack. Thanks a lot. Questions to Gautier? Well, I think all those people will sit in your workshop this afternoon.
Thank you.
I guess. Oh, there is a question. Yes?
Yeah.
hear me? Can you hear me now? Yeah. Thanks for a nice presentation. I would like to know how many reptilians or J-Quartans were injured during your development.
Actually, it's a very, very good question because you cannot be injured with Android things because you can just use Mockito to mock devices. So you will not mock you will not use a real chainsaw and cut your fingers because you know when you try something it never works and then you go to Stack Overflow and it works. So you just mock your devices, you mock your chainsaw, you mock whatever you like and it will be safe for you and then you can use the machine. The machine is hidden somewhere so I will not tell you where obviously.
Thanks again, Gautier.